This is the EdExcel AS level further maths paper 2 covering the FP1 module, and this is from the 2022 series. Question number 1. We have to use algebra to find the set of values of x for which x is greater or equal to 2x plus 15 over 2x plus 3. Now, we begin this question by multiplying both sides by 2x plus 3 all squared. And what you will find is, on the right hand side, this cancels with this once. And so what we have is x multiplied by 2x plus 3 all squared being greater or equal to 2x plus 15 multiplied by 2x plus 3. And now if we take everything over to one side, we have x multiplied by 2x plus 3 all squared, subtract 2x plus 15 multiplied by 2x plus 3 being greater or equal to 0. And at this point we can recognize the 2x plus 3 is a common factor to both terms, and so if we factorize, we have 2x plus 3 multiplied by x multiplied by 2x plus 3 subtract 2x plus 15, and this is greater or equal than 0. Now what we can do is expand this bracket. So we've got 2x plus 3 being multiplied by, well, x multiplied by 2x. We end up with 2x squared, x multiplied by 3. That's 3x, negative 1 multiplied by 2x. That's negative 2x. Negative 1 multiplied by 15 is negative 15. And this is greater or equal than 0. So, collecting like terms, we have 2x plus 3 being multiplied by 2x squared plus x, subtract 15 being greater or equal than 0. And this bracket we can now factorize as the product of two linear brackets. So we've got 2x plus 3 being multiplied by, well, factorizing, we end up with 2x subtract 5 multiplied by x plus 3. And this is greater or equal than 0. And so what we can conclude here, for our critical values, x will equal negative 3 over 2. We also have x equals 5 over 2 and x equals negative 3. Now at this point we can draw a number line showing our critical values. So here is our number line with the critical values shown here. Now we'll test values either side of these critical values. For example, if we test something smaller than negative 3, such as negative 4, well, what we can do is substitute in this negative 4 there back into here. So we have 2 times negative 4 plus 3 multiplied by 2 times by negative 4 subtract 5 multiplied by negative 4 plus 3. We end up with negative 65. What we have is a negative value. Now let's test a value in between negative 3 over 2 and negative 3, such as negative 2. Substituting that back into here, we have 2 times negative 2 plus 3, 2 times negative 2 subtract 5, negative 2 plus 3, we end up with 9, something positive. Let's now test a value in between negative 3 over 2 and 5 over 2, such as 0. Well, we've got 3 times by negative 5 times by 3. That, of course, will be negative. And let's test something greater than 5 over 2, such as 3. Well, we've got 2 times by 3 plus 3. 2 times by 3 subtract 5 multiplied by 3 plus 3, which is 54. What we end up with is something positive. And so what we can see is our solution is greater or equal to 0 when x is in between negative 3 and negative 3 over 2, or when x is greater than 5 over 2. And therefore, for our solution, we've got x belonging to a set of real numbers. We have negative 3, which is less than or equal to x, which is less than or equal to negative 3 over 2. Or we have x being greater or equal to 5 over 2. Here is our solution to the inequality. Question number 2. A population of deer was introduced onto an island. The number of deer, P, on the island at time t years following their introduction is modelled by the differential equation dp over dt equals p over 5000 multiplied by 1000 subtract p multiplied by t plus 1 over 6t plus 5, where t is greater than 0. It was estimated that there were 540 deer on the island 6 months after they were introduced. we have to use two applications of the approximation formula dy over dxn being approximately equal to yn plus 1 subtract yn over h to estimate the number of deer on the island 10 months after they were introduced. Now, the steps are 2 months, and that's because we've got two applications of the formula being used from 6 months to 10 months, which means we've got 2 months out of a total of 12 months in a year, which means h is equal to 1/6. Now we know that 6 months after they were introduced, we've got 540 days. So what this will represent is T0 equaling one half and P0 equaling 540. Now, if we take this 1/2 and add to this 1/6, we get 2/3 for the value of T1. So T1 is equal to 2/3 and T2 will equal 5/6. Now, if we use our approximation formula, well, we can see that if we arrange it, we end up with yn plus 1 being approximately equal to yn plus h multiplied by dy over dxn. Now, before we do anything else, because we know T0 and P0, what we can find is dp over dt naught, and we can find that using this formula here. So dp over dt naught, this is equal to P0 over 5,000 multiplied by 1,000 subtract P0 multiplied by T0 plus 1 divided by 6 times by T0 plus 5. So, substituting in for T0 and P0, we have 540 divided by 5,000 multiplied by 1,000 subtract 540 multiplied by 1/2 plus 1 divided by 6 multiplied by 1/2 plus 5. So let's work out what this is. Well, typing this into our calculator, we end up with 97.065, and now what we can do is find out what P1 is using this formula here. So P1, that is approximately P0 plus H multiplied by dP over dt naught. So we have P0, which is 540, plus H, which we know is 1/6, multiplied by dP over dt naught, which is 97.065. So if I divide this value by 6 and then add on 540, it turns out P1 is equal to 556.1775. Now let's find out what dP over dt1 is. So dP over dt1, that's equal to P1 over 5000 multiplied by 1000 subtract P1 multiplied by T1 plus 1 over 6 times by T1 plus 5. So substituting everything that we know, we have 556.1775 over 5000 multiplied by 1000 subtract 556.1775 multiplied by, well, T1 we mentioned that's equal to 2/3, so we multiply this by 2/3 plus 1, and then we divide this entire thing by 6 multiplied by 2/3 plus 5. So now let's type all of this into our calculator. We've got this value over 5000 multiplied by 1000 subtract. We've got this value multiplied by 2/3 plus 1 over 6 times by 2/3 plus the 5. So what we end up with is a value of 99.77870 0.698. So now that we know what dp over dt1 is, what we can now do is find out what p2 is using the iterative formula. So P2 that is approximately equal to P1 plus H multiplied by dP over dt1. So we've got the value we had here, 556.1775 plus H, which is 1/6, multiplied by dP over dt1, which is 99.778,706.98. So if I divide this value by 6 and then add on to this 556.1775, what we end up with for P2 is 572.8072845. And so what we can conclude from here then is estimated to be 572 deer after 10 months. Question 3, part A. We have to use t equals tan of theta upon 2 to show that where both sides are defined, 29 subtract 21 sec theta over 20 subtract 21 tan theta is equivalent to 5t plus 2 over 2t plus 5. Now to begin with, if t is equal to tan of theta upon 2, then sine theta is equal to 2t over 1 plus t squared. Cos theta is 1 subtract t squared over 1 plus t squared. And tan theta is 2t over 1 subtract t squared. So if we focus on the left hand side, well, we've got 29 subtract 21 sec theta, and then we divide this by 20 subtract 21 tan theta. Now sec is the same as 1 over cos. So we have 29 subtract 21 multiplied by 1 over this, which is 1 plus t squared over 1 minus t squared, and then all of this is being divided by 20 subtract 21 tan theta, so we have 21 multiplied by 2t over 1 subtract t squared. So if we simplify this result by multiplying both the numerator and the denominator by 1 subtract t squared, then we would have 29 multiplied by 1 subtract t squared subtract 21 multiplied by 1 plus t squared. And then for the denominator, we have 20 multiplied by 1 subtract t squared, and then we subtract 21 multiplied by 2t. So on the top we have 29 subtract 29 t squared subtract 21 subtract 21 t squared, and on the bottom we've got 20 subtract 20 t squared subtract 42 t. And if we simplify by collecting like terms, on the top we have 8 subtract 50 t squared, and on the bottom we would have negative 20 t squared subtract 42t plus 20. Now from the top and bottom we can factorize out a negative 2. So I've got negative 2 multiplied by 25 t squared subtract 4 over negative 2 subtract multiplied by 10t squared plus 21t subtract 10. Now the negative 2's simplified to 1 on the top and bottom, leaving us with 25 t squared subtract 4 divided by 10 t squared plus 21t subtract 10. Now the top and bottom can be factorized. On the top we can factorize as a difference of 2 squares, so we have 5t plus 2 multiplied by 5t subtract 2, and on the bottom we have 5t subtract 2 multiplied by 2t plus 5, and therefore what we end up with is 5t plus 2 over 2t plus 5. So because this result is equivalent to what we see on the right hand side, the result has shown to be true. For part B of the question, again using t equals tan of theta upon 2, we have to prove that where both sides are defined, 20 plus 21 tan theta over 29 plus 21 sec theta is equivalent to 21 9 subtract 21 sec theta over 20 subtract 21 tan theta. So on the left hand side we begin with 20 plus 21 tan theta divided by 29 plus 21 sec theta, and using the t formulae we have 20 plus 21 multiplied by tan theta, which is 2t over 1 minus t squared, divided by 29 plus 21 multiplied by 1 plus t squared over 1 minus t squared. And at this point, if we multiply both the numerator and the denominator by 1 minus t squared, we would have 20 multiplied by 1 subtract t squared plus 21 multiplied by 2t over 29 multiplied by 1 minus t squared plus 21 multiplied by 1 plus t squared. Now let's expand out. We've got 20 subtract 20 t squared plus 42 t on the top, and the bottom we've got 29 subtract 29 t squared plus 21 plus 21 t squared. And if I simplify on the top, we would have negative 20 t squared plus 42t plus 20, and on the bottom we would have 50 subtract 8t squared. Now we can factorize a negative 2 from the top and bottom. So I've got negative 2 multiplied by 10t squared subtract 21t subtract 10, and on the bottom, if I factorize out a negative 2, we would have 4t squared subtract 25. The negative 2 simplified to 1, and therefore we will be left with 10t squared subtract 21t subtract 10 over 4t squared subtract 25. So, factorizing, we have 2t subtract 5 multiplied by 5t plus 2, and on the bottom we have 2t plus 5 multiplied by 2t subtract 5. And simplifying even further, we end up with 5t plus 2 over 2t plus 5, and if we recall, this is the result we started off with. So we have this result being the same as 29 subtract 21 sec theta over 20 subtract 21 tan theta. And so because all this is equivalent to the right hand side, we have shown this result to be true. Question number 4. The parabola C has equation y squared equals 10x. The point F is the focus of C. For part A, we have to write down the coordinates of F. Well, for part A, what we have so far is y squared, which is equal to 10x. And if we rewrite this such that we have y squared equals 4ax, we would have y squared equals 4 multiplied by something multiplied by x. Now 4 multiplied by 5 over 2 will give the 10, and this is being multiplied by x. So the value of a is 5 over 2, and therefore the coordinates of f, we have 5 over 2, 0 as the coordinates of the focus. The point P on C has y coordinate q, where q is greater than 0. What we have to do is show that an equation for the tangent to C at P is given by 10x subtract 2qy plus q squared equals 0. Now, what you can see here is we've got our parabola with the focus at the point F. And we also have our directrix shown here. Now, what we have is some point P on the curve, and what we need to do is find the tangent at this point P here. So what you can see here then is the curve, the point P, the focus, the directrix, and this tangent, and we need to find that tangent. Now, before we do anything else, we need to find out what dy over dx is. Now, dy over dx, this is equal to 2a over y, and we know what a is. That's equal to 5 over 2. 2 times by 5 over 2 is 5. So we have dy over dx equaling 5 over y. Now, when y is equal to q, we can find out what x is and what dy over dx is. So, dy over dx will equal 5 over q, and if we use the equation y squared equals 10x, then when y equals q, we have q squared, which is equal to 10x, from which we can conclude x is equal to q squared over 10. And therefore, the coordinates of P, we've got q squared over 10 for the x coordinate, q for the y coordinate. So let's add this to the diagram. We've got the coordinates of P, q squared over 10, q, and whilst we're here, F has coordinates 5 over 2, 0. So the tangent has equation y subtract q equals 5 over q, which is what the gradient of the tangent is, multiplied by x subtract q squared over 10. And at this point we need to simplify all this. So if I multiply through by q, we've got yq subtract q squared equals 5 multiplied by x subtract q squared over 10, and if I multiply the 5 into this bracket, we have yq subtract q squared equals 5x subtract q squared over 2. 5 times the 10th is a half. And if I multiply through by 2, we've got 2yq subtract 2q squared equals 10x subtract q squared, and taking everything over to one side, the tangent would have equation 10x subtract 2qy plus q squared equals 0. Now, the tangent to C at P intersects the directrix of C at the point A. The point B lies on the directrix such that PB is parallel to the x-axis. We have to show that the point of intersection of the diagonals of quadrilateral PBAF always lies on the y-axis. Now, the first thing, this tangent intersects this directrix at the point A, which is what we see here. We know that the point B lies on the directrix and BP is parallel to the x-axis, which means B has the same y-coordinate as P. And what we've got is this quadrilateral AFPB. Now, what we have to show is the diagonal of this quadrilateral. When those diagonals intersect, they intersect always along the y-axis. So, if we've got this diagonal as well as this diagonal, what we need to show is they intersect along the y-axis as q varies. So what you can see here is as q varies, this point of intersection, which is here, is always along the y-axis, and that's exactly what we need to show. So that is what's being demonstrated here. As q varies, this point of intersection would always lie on the positive y-axis. So here is that shown in this diagram. And what we need to do is find out the coordinates of A and find out the coordinates of B. Now, the coordinates of B will be quite straightforward to work out. B lies on the directrix, which means its x-coordinate is -5/2, and its y-coordinate will be the same of that of P's Q. So here is the coordinate of B. And what we also need to do is find out the coordinates of A. So to find out the coordinates of A, we need to find out where this tangent intersects the directrix. Now, first of all, if we take a look at our equation for the tangent, what we can do is rewrite that as following. We can rewrite this as y equals 10x plus q squared over 2q. So this is an alternative form for that tangent. Now, when x equals -5/2, we can find out the corresponding y-coordinate. Y would equal 10 multiplied by -5/2 plus q squared over 2q. So, if we simplify this, what we can see is y equals 25 multiplied by -1, so we have q squared subtract 25 over 2q. And therefore, we can conclude for the coordinates of A, the x-coordinate is -5/2, and for the y-coordinate, we've got q squared subtract 25 over 2q, as we see here. So this is the coordinate of A, as we see here. Now, what we can do is find out the intersection point here. So the way we can do that is to first of all find out the equation of BF. And to find out the equation of BF, well, what we need to do first, the gradient of BF, well, we've got q subtract 0, and then we've got -5/2 subtract 5/2. So the gradient of BF then is equal to -q over 5. So the equation of BF, well, it passes through the point F with coordinates 5/2, 0. So we've got y subtract 0 equals -q over 5 multiplied by x subtract 5 over 2. Now, we need to find the intersection between this line and the tangent. Now, the tangent over here I'm going to call equation 1, and this equation I'm going to call 2, and what I'm going to do is substitute in equation 2 into equation 1. So I've got 10x subtract 2qy, but I already know what y is. Y is this result over here. And then what I need to do is add on q squared, and the result of this is equal to 0. So let's simplify this even further. We've got 10x subtract 2q, and then I'm going to multiply this by, well, here I've got minus q over 5x plus, now here I would have q over 2. And let's close this bracket. And then I would add on q squared. This is equal to 0. Now let's expand out. So we have 10x well, here I would have positive 2q squared over 5x subtract q squared plus q squared equals 0, and the negative q squared and the positive q squared give a 0 pair, and if I factorize out an x, I would have x multiplied by 10 plus 2q squared over 5. This is equal to 0. Now the 10 plus 2q squared over 5, that's going to be greater than 0 because q is greater than 0. So this bracket is not 0, which means x is equal to 0. So what we're saying is this point here always has an x coordinate of 0, and therefore what we can say from that, the intersection would lie on the y-axis. Question number 5. The points A, 3, 2, minus 4, B, 9, minus 4, 2, C, minus 6, minus 10, 8, and D, minus 4, minus 5, 10 are the vertices of a tetrahedron. The plane with equation z equals 0 cuts the tetrahedron into 2 pieces, one on each side of the plane. The edges AB, AC, and AD of the tetrahedron intersects the plane at the points M, N, and P respectively, as we see in figure 1. We have to determine the coordinates of the points M, N, and P for part A. Now let's add in what we know so far. We've got the coordinates of A, 3, 2, minus 4. Coordinates of B, 9, minus 4, 2. Coordinates of C, minus 6, minus 10, 8, and the coordinates of D, minus 4, minus 5, 10. So what we can do now is find out those coordinates. We can recognize that M lies on AB, N lies on AC, and P lies on AD. So the line segments AM, AN, and PN are fractions of those lines. So what we can do to begin with is find out AB, AC, and AD. So for part A, if we begin by finding AB, then AB, what we are doing is we are starting at A, finishing at B. Well, from 3 to 9, I add on 6. 2 to minus 4, I subtract 6. Minus 4 to 2, I add 6. So what we have here for the coordinates of AB will be 6, minus 6, and 6. Now we can find out AC. So to find out what AC is, well, from 3 to minus 6 we subtract 9, from 2 to minus 10 we subtract 12, from minus 4 to 8 we add on 12. So we've got coordinates given, and therefore finding AC we have minus 9, minus 12, and 12. And AD can also be found if we find out what AD is. Well, from 3 to minus 4 we subtract 7, 2 to minus 5 we subtract 7, and minus 4 to 10 we add on 14. So AD, we've got minus 7, minus 7, and 14. So now we can find out the coordinates of M, N, and P. Now, if I find out what the vector OM is, well, to find out what OM is, I can start at A, but then I can go a certain fraction in the direction of AB. Now, what is that certain fraction? Well, what you will find here, from A to this line, I add on 4 units. From minus 4 to 0, I add on 4. Now, if we think about the z coordinates, from minus 4 to 2, I add on 6. So we have 4/6 of that to get to M. So for OM, we start off with OA to 3, 2, minus 4. And then what we do is add on 4/6 of 6, minus 6, and 6. So if we work out what this is, we end up with 7 minus 2, 0. Next, we can find out what ON is with a similar argument. Now, from A to C, from -4 to 8, we add on 12, and therefore AN is 4/12 of AC. So for ON, we start off at A and then we add on 4/12 of AC, which is -9, -12, and 12. And if I work out what this is, we end up with 0, -2, 0. And similar argument, we can find out what OP is. Well, for the Z coordinates, from -4 to 10, we add on 14. So AP is 4/14 of AD. And therefore, OP is 4/14 of AD. So here we've got -7, -7, 14, and therefore what we end up with is 1, 0, 0. So therefore the coordinates of M, we've got a coordinate of -7, or the +7, to 0. N, we've got coordinates 0, -2, 0, and P having coordinates 1, 0, 0. So what we'll do is we'll add these to the diagram. So we've added on those coordinates. For part B of the question, we have to find the area of the triangle MNP. Now, if I was to find out the area of this triangle, what I need is the vector MP and the vector MN. Finding the cross product of those and then the magnitude and then multiplying that by a half will find for us the area of that particular triangle. So to go from M to P, well, I'm starting at M, I'm finishing at P. We have -6 to 0, and the vector MN, that's equal to, well, M to N, we've got -7, then we've got 0, 0, and now if I find the cross product MP with MN, well, we've got these two vectors crossed. So if I go to the vectors sub-menu, define vector A, -6 to 0, then define vector B, -7, 0, 0, and then if I have A and cross that with B, I get 0, 0, 14, and therefore what we can say, the area of MPN, that's equal to 1/2 multiplied by the magnitude of MP cross with MN so we've got 1/2 cross with 14k, so the area in this case is 7 units squared. Now for part C we have to determine the exact volume of the solid B, C, D, P and M, which is the remaining volume when we get this shape and slice it about the plane z equals 0. So this is the volume we need to find. Now, to do that, well, I can find out this smaller volume of the tetrahedron, the larger tetrahedron, and then subtract them. Now for the smaller tetrahedron, well, if I know this area of this triangle, I can find out the vector MA and then find the volume of A, M, N, P. So, if I find out the vector MA, well, what we have is -4, 4, 4 as the vector MA, and that's because from 7 to 3 we subtract 4, 2 to -2 we subtract 4, and then 0 to -4. Here is the vector MA. Now, to find out the volume of A, M, and P, well, what we have is 1/6 times the magnitude of the vector MA dot with the cross product between MP and MN. So we can work this out. So if I work out what this is, I've got 1/6 multiplied by, well, here I've got -4, 4, -4 dot with MP cross with MN, which we've worked out to be 0, 0, 14. So what we have then is -4 times by 14, and then that's 56, and then dividing that by 6, what we end up with is a volume of 28 over 3 units cubed. Now, if I consider this larger tetrahedron, well, what I need is BA, then I need BD and BC. So let's find each of those. Well, here are the vectors BA, BC, and BD. BA is -6, -6. BC is -15, -6, 6. BD is -13, -1, and 8. And so what we can do at this point is find out what BC cross with BD is. So if I work out what this is, I've got this vector cross with this vector here. So working this out, well, let's define these vectors. So what I can do is cross this with that vector, and what we will be left with is minus 42, 42, and minus 63. So that is BC crossed with BD. And now I know this triangle, I need to dot product this with BA. So the volume of A, B, C, D, I've got 1/6 multiplied by BA dot width the cross product between BC and BD. So let's work this out. I've got 1/6 of, well, I've got BA, which is this vector here, and then what I need to do is dot this with this vector here. So if I work out what this is, well, what we'll do is let's define a new vector C to be -6, 6, -6, and then we will take this vector C and we will dot product this with the previous answer we just worked out. So we have a value of 1/6 of 882, and if I divide this by 6, I end up with 147 units cubed, and therefore the volume of BCD PNM, we've got 147 subtract 28/3, which is 413/3 units cubed. And that's exactly what we wanted to work out.